distinguished guests, all dignitaries, ladies and gentlemen, a very good afternoon to one and all present here. Today is a very special day for all Indians. Today we are celebrating our 73rd Republic Day, and I wish a very happy Republic Day to everyone. It is my great pleasure to welcome you all to the first ever collaborative science exhibition organized by St. Augustine's Day School, Barrackpore and Canadian Bilingual School, Kuwait. Every year, our school organizes an annual science exhibition, but this year it is really special. This year, we are organizing this event on such a significant day and in collaboration with Canadian Bilingual School, Kuwait. I welcome our chief guest for the occasion, Madam Jihan Mohammad Hassan, Principal, Canadian Bilingual School, Kuwait, and our guest of honor, Ms. Mohana Mukherjee, Principal, Multicultural Academy, Michigan, USA. I would especially like to welcome the parents and guardians of all our students who have joined us to witness today's program. Let us begin our program by showing our respect and gratitude towards our countries by playing the national anthem of both the collaborating schools. Ladies and gentlemen, science can change our future. The future of our society lies in the hands of aspiring young people who can motivate, cooperate with others, and stay resilient will be able to rise up to challenges and make our earth a better place. So today, we have budding scientists and innovators here with us, all ready and excited to show their projects. In our efforts to build global citizens, our school is collaborating with Canadian Bilingual School, Kuwait, and Multicultural Academy, Michigan, USA. Coming in close association with the students of these schools is providing an opportunity to our students to witness and understand the culture and ethos of the students from different parts of the world. We are honored to have with us Ms. Mohana Mukherjee, who is our guest of honor. Ms. Mukherjee is the principal of Multicultural Academy, Michigan, USA. Thank you so much for joining, ma'am. I request you to share a few words with all of us.
Hello, everyone. Thank you for inviting me to be your guest of honor at the annual Science Exhibition and Fair. It is my privilege to be addressing and talking to the amazing group of educators, students, staff, parents, and the community. I must tell you, when I got your invitation, a memory came flashing back in me. I wasn't always good in science. When I was in school, I was a part of an experiment for a science exhibition, and I decided to go innovative last moment. I put an acid on fish on a petri dish. I was expecting colorful change of colors, and I was thinking that I will amaze the audience. You know what happened? There was a reaction, a chemical. And then the fish blew up. There were flesh and scales all over the ceiling. That is how I started my journey into the world of science. But that day made me think that science is wonder. Tomorrow depends on what we do with science today. And I must tell you, students, my journey of being into education started from that failure of a science experiment that I had. It made me think that if my students get the right help, guidance, methods, technologies, and all the avenues, they will be the scientists of tomorrow who will make amazing changes to have a better tomorrow. Your generation is privileged. You probably have everything that we in our time never even dreamt of. It is your time to shine bright. It is your time to let your mind go free. It is your time to let your mind go tinkering. Think of the impossible. Dream of it. Find a way to try it and then make it happen. I'm sad that this year we are doing the science exhibition in remote. I hope to join you in person sometime soon. I hope to interact with you. I hope to see your eyes and feel your dreams. And I hope that one day from your school, you will have people go to NASA. You will make robots. You will have breathtaking discoveries in medical science. You will make inventions that will change the world. And it all starts with your intentions today. It all starts with your thinking of yesterday. And it all starts with your dream of tomorrow. So enjoy your time. And from other side of the world, I wish you the very best. Thank you. Hello, everyone.
Thank you so much, ma'am. Thank you for your words of wisdom. With those inspiring words, we begin our program. I hand over to Jara Adil, student of Canadian Bilingual School, Kuwait, to carry on with the proceedings. Over to you.
Hello. Hello. Good morning.
Yes. You're absolutely audible, but we cannot see you. But you're audible.
I have my camera. I have two accounts, so if you can take my other account, both of them are Jarrah.
Okay. Please continue.
Okay. Good morning. My name is Jarrah. I'm a student. I'm a grade 11 student and honored to participate with my school, Canadian Bilingual School Kuwait, in this amazing event. Our HS will be presenting experiments conducted by the students. We hope you benefit and enjoy our presentations. Thank you for your collaborating with us on this wonderful event. Have a great time, and I hope we can collaborate in future events. Good luck for all the young scientists. To CBS students, thank you so much for all your effort, and we Look forward to more scientific success. Thank you.
So we will have the presentation now. We'll have the science display by the Canadian Bilingual School. Please bear with us, dear audience. We are having some technical issue. Please bear with us.
Yes, I have shared my screen. Can you see it?
Yes, it is visible. Yes, it is absolutely visible.
Hello everyone, I'm Ibtisam Nasser. I hope you're doing fine. And today, me and my fellow classmates, Dima Talal and Isma Yusuf, will explain chromatography and the purpose of it.
Chromatography is a technique used to separate mixtures. This project's purpose is to utilize paper chromatography to determine which dyes are used on coating your favorite colored candy. Finally, as was the case with these pigments, chromatography technique were utilized to divide items based on their hue.
Hello everyone, myself Jaden from CBS, Class 7A here, with my classmates Qadi and Sabar, representing you all the model of a volcano.
For this model, we have used old newspaper, plastic bottles, glue, black and red food coloring, baking soda, dish soap, and vinegar.
Here carbon dioxide gas is produced. Pressure builds up inside the plastic bottle until the gas bubbles out of the volcano.
This is a good representation of what happens in real volcanoes.
Hello, my name is Elise Khan from grade 9A, and in this experiment I'll be demonstrating how oxygen is liberated during photosynthesis. Photosynthesis is a process by which plants use light, water, and carbon dioxide to create oxygen and energy in the form of sugar. Plants use water plus carbon dioxide, which makes energy, as well as glucose and oxygen. In this experiment, we will need a beaker, a funnel, and a test tube, and a few tweaks of an aquatic plant such as Hinoki cypress, hydrilla, cara, alodia, etc. To begin this experiment, take the plant and insert the cut ends of their stem into the tube of the funnel. Now carefully put the funnel into the bottom of the beaker filled with water. Next, fill the test tube to the brim with water and let it sit over the tube of the funnel. Your setup is now done. You may also add a pinch of potassium bicarbonate into the beaker to start the photosynthesis process. Place the setup in sunlight or in front of a lamp, just as I did. A few minutes after exposure to sunlight, you will see small air bubbles form into the bottom of the funnel, and these air bubbles will travel through the tube of the funnel and will eventually collect in the upper end of the tube. Now leave the setup in light until the test tube is fully filled with gas. Now carefully remove the test tube from the beaker while covering the mouth of the tube with your thumb. Remove the thumb and immediately put a glowing splinter into the tube. You will notice that the glowing splinter reignites with a pop sound. This experiment confirms that the gas produced by the aquatic plant and collected by the test tube is indeed oxygen. So this experiment shows that oxygen is evolved during photosynthesis in green plants. So this is how my experiment went.
Hi, I'm Ragad from 9A and today I'm going to show you my circulatory system project. As you can see, this is the heart, the arteries in red, and the veins in blue. The arteries in red deliver oxygenated blood and nutrients to all of the body's tissues, and the veins in blue return oxygen-poor blood back to the heart. I came with the idea of this project when I wanted to see how can the blood move around the whole body. So I thought this is how it looks like.
This is 9B. My name is Fahad, and this is Abdullah and Abdul Hadi. Us three made a project about the water purification system.
This project consists of a pump and a tank. The pump pumps the water into the filter. The filter then cleanses the water and purifies it, and then goes through the pipeline and into a container that has the final result.
We thought of this idea to help the society improve. We can improve it by making dirty water into good water. If we can change our sea into purified water that is crystal clear, it would help the sea and remove the wastes. Our idea is inspired by the filtering system in houses. Ever see the big tank in some houses? Yes, it is connected to a pump and tubes and then connected to the sink, where it is purified the water. Ours is basically the miniature version, and we hope we strive for a better future. And this is the ending of our project.
Hello, Ms. White. This is our video about our experiment, bath bombs in water. The members in this experiment are Sayyid Hashim, Abdullah Anwar, me and Khalid. Khalid and Abdullah Anwar showed systems of COVID, so they were sent home.
First of all, we want to thank Ms. White and ourselves and our team, because we helped each other and we finished our project in one time.
The table of contents, you can see each slide and what you're going to see on each slide and read them.
Statement of purpose. The purpose is to understand how water reacts with the total combination. So for instance, right now we will use bath bombs that we want. We know bath bombs have chemicals inside them, so we would like to see how it reacts with water.
Hypothesis. Our educated guess would be that the chemicals inside the bath bombs would react with the water, due to them being liquid and solid. But at the same time, we know that there are chemicals that were actually used to actually make the bath bombs. And also, bath bombs would react to water when thrown into it. It affects the way the bath bomb looks, and also it loses its shape and starts to melt. Or you could say it dissolves in the water.
Research. Well, firstly, what are bath bombs made of? Bath bombs are usually made from the key ingredients: baking soda, citric acid, and cornstarch. Also, because carbon dioxide is a gas, it forms more bubbles in the bath water. Secondly, how does water react to bath water again, you may be asking? Well, bath bombs fizz when water triggers a reaction between an acid and a neutralizing substance known as a base. The dry chemicals are stable, but in water they react together to produce carbon dioxide bubbles. Thirdly, we also know that the temperature actually matters to how the bath bomb dissolves in the water. In our experiment, we will be using room temperature water.
As you can see, the materials used, we basically don't have a long list because all we have and all we use are water, oil, and bath bombs.
How the experiment should go? The experiment should go the expected way, which is the normal reaction we see when we put shampoo and color into the water. The water will keep its shape, but the bath bomb will dissolve in the water and it will continue. Now it will combine and change the color of the water. Basically what we expect is a color and smell change. When a bath bomb comes in contact with water, the baking soda and citric acid react to make carbon dioxide bubbles. This is an acid-base reaction, where baking soda, also called sodium bicarbonate, is a weak base and citric acid is a weak acid.
Procedure. We get a bowl full of room temperature water, right here, and then we'll get our bath bombs and place them into the water. We'll watch the bath bombs dissolve into the water, and we can actually hear the bubbling that shows us that there's a chemical reaction. Because we know that chemical reactions are change of smell, change of formation, and change of change of smell, change of formation, and change of color. We'll also see what happens, and we'll see if our hypothesis is actually correct, and basically the experiment will be done by them.
The results that we got at the end is that the bath bombs will react with the water, and therefore our experiment and notes that we have wrote will have been correct, and as we already said, already stated before, the chemical reaction occurs, and we know it's a chemical reaction because of the smell change and the color change.
These are the references. Now we'd like to actually do the experiment. We have the room temperature water right here, and then we'll have Hashim throw in the bath bomb, and we'll see how it reacts. You can see the fizzling and the bubbling right there. If you can put it up, look, the fizzling and the bubbling, and look at it dissolve. It's dissolving right in front of our eyes.
Unfortunately, the bath bomb we brought ripped just now.
And as you can see, the color change is occurring as well, but this would be it would need longer time to actually dissolve with the water. But right now, we can see that our hypothesis is correct, and a smell, if you can smell it, has changed, and also the color of the water has started to change. And slowly and surely, it will actually all change. Thank you.
Yeah, and also temperature changed.
So first we're going to put 6 tablespoons of apple cider vinegar. Okay. So, it's okay with me. 3, 4, 5. That's not 6. Okay, now 3 tablespoons.
3 is not too much. Just put 2 first.
2?
Try, yeah, start.
No, it's just
Okay.
It's okay, 2 is okay.
Okay, 2.
Any control.
I think it's okay too. It's enough too.
2 is enough.
Okay.
You sure?
Enough too. No need more.
Now the baking soda.
Now the baking soda. Okay, done. Ready the timer?
Yeah. We put it inside.
Okay.
How many spoons you will put?
This one.
Only one, and just a little piece at the beginning.
No, it's not gonna be something big.
Too much bleed.
It's okay.
It's one.
It's okay.
So low. Yeah, no,
3, 2,
2, 1, go.
So as you can see now, the vinegar is reacting with the baking soda, and now he's measuring the time, see how long it's going to last. We stop the timer when we see like most of the bubbles stop.
Why we call this a chemical reaction?
Because the vinegar is reacting with the baking soda.
What are the signs of the chemical reaction? You can
Formation
say
of bubbles and the formation of the foam, and there is like a small change of color in the other.
Okay, what about the second vinegar you have?
We're gonna start the second one, time it when this one's done. So when most of the bubbles are like gone, we stop the timer.
Which one you did it before it was better, the balsamic vinegar or the apple vinegar?
Better one is balsamic, that will react.
It will move.
It will not react more, but it will react longer, which means it's having a bigger chemical reaction.
Very good. It's okay, start the other experiment, keep this, maybe it will take 2 or 3 minutes. How many spoons you will put?
6 tablespoons.
Good.
10,
You have to put the same number of
So this
spoons.
one, so this one took 1 minute and 6 seconds. Until now it's
Yeah, measure the time, 1
Now we're
minute.
gonna 1 minute 6 seconds.
Okay.
So same thing as we did with this one. 6 tablespoons of vinegar, 2 tablespoons of the dishwashing soap, and then 1 tablespoon of balsamic. That's one.
The same amount, please just put 2.
2.
Yeah, 2 spoons.
Yeah. Not big soda.
Okay, let the timer run.
Ready?
3,
Yeah.
2, 1, go.
Now this one is gonna act much
This is gonna
longer,
react.
so that's why it's way slower. It's gonna take seconds.
It starts slower than.
It will rise up after time.
How many minutes did you do yesterday? This one starts.
Yesterday it took like maybe 3 minutes to actually reach the height, and
Yeah.
it's way longer than this one because it reacts much more.
The rate of this chemical reaction, which one faster? What do you
This
think?
one's faster, but has
Yeah.
a less chemical reaction.
Do you know
But
why
this-
it's faster?
I think it's faster because, as we said, it's more acidic. It's more acidic and
More
like
acidic,
tangy.
yeah, that's it. Okay, thank you guys.
Can water be magnetized? By Muhammad Ali and Muhammad Arif. Can water be magnetized? Under the influence of a magnetic field, water can be magnetized, and several of the features of magnetized water, such as surface tension, pH, viscosity, electrical conductivity, and scale formation inhibition, have proven valuable in businesses. When a magnetic field is applied to water, the surface tension drops while the pH rises. In addition, magnetized water's shear viscosity rises, and the magnetic field prevents scale development. This study examines magnetized water's distinctive features, as well as its prospective applications in the oil industry as a smart and ecologically friendly fluid, such as an injection fluid in enhanced oil recovery areas for generating oil. Materials used in the experiment. The materials used in the experiment are a large box, styrofoam layer, small cup, tiny pinch of blood, and 10 cups of water. Hypothesis. It is impossible to magnetize water. My theory is based on what I've learned about the materials that can be magnetized, and water isn't one of them. Water cannot be a permanent magnet if it's pure. However, it can be magnetized for a short period of time. My theory is based on the knowledge I've acquired about the attraction force between atoms and molecules of many substances, including water. There appears to be a connection between these forces and magnetic forces. I think in the experiment the water might be able to magnetize for a minimum amount of time only. And if my guess is wrong, that would be okay because I would learn something new. Planning and steps. This is the experiment that we will do. Step 1. We will base the experiment on our hypothesis and bring a large box, filling it up with water, then mix a tiny bit of blood, which contains iron. Step 2. We will then use a small styrofoam layer which is placed on the water-filled box. Step 3. We will take the cup that has a pinch of blood and place it on the styrofoam layer. Step 4. We will use a powerful magnet to check if the water got magnetized. How will we measure the result? We will base the results on if the cup ends up moving using the magnet. The experiment.
Hey Magnet fans! This video is kind of a follow-up to Brainiac 75's awesome video about whether powerful magnets will attract to the iron in our blood. If you haven't seen it, you should definitely go check that out first. In his video, a small cup of blood was placed on a piece of styrofoam floating in a bucket of water. It's a great trick to show the weak diamagnetic forces from a strong magnet to the small cup of blood. The force is very tiny, but it does repel the little cup of blood just a tiny bit. While we were watching it, it occurred to us that the effect might not have anything to do with how hemoglobin reacts in a magnetic field. After all, blood's about 50% water. No matter how much that tiny amount of iron in red blood cells might react, you might still see the diamagnetic repelling action because a strong neodymium magnet repels water. There are a lot more water molecules in his cup of blood than iron molecules. Anyway, this short video shows the same kind of diamagnetic repulsion between a magnet and a cup of water.
Alright, so that was the experiment. Now, the conclusion. A complete pure water cannot be affected by magnet, but water can be magnetized if it is not completely pure because it may contain other contents such as iron, copper, sulfide, and etc. We also found out that the magnetic field was helping in repelling the object that is holding the water, so that took place in the experiment too. In conclusion, water can be magnetized if it has contents that are attracted to magnet in it. The data record, Saturday, 27th of November, 2021. Time, 3 p.m. afternoon. In the first experiment, it was a success. It worked fine for the second time too. Resources used for research. These are all the resources we used for the research. Thanks for your attention. I hope everyone enjoyed.
Hello everybody, my name is Abdulaziz Abdussalam Al-Rashidi and today I'm going to present to you our science fair project with my group mates Fad Nawaf Al-Shahin, Mohammed Faisal Al-Gallaf and Athman Mshari Al-Kuh. And our topic is aerodynamics. In our first slide, which is what are aerodynamics? To put simply, aerodynamics are the ways that air moves around things. The rules of aerodynamics explain how an airplane is able to fly. Anything that moves through the air reacts to aerodynamics. A rocket blasting off the launch pad and a kite in the sky reacts to aerodynamics. Aerodynamics even acts on cars, since air flows around cars. Examples about aerodynamics. Some technologies that depend on aerodynamics are cars, bicycle racing, helmets, wind turbines, and golf balls. Since air is all around us, there are many examples of aerodynamics technology other than for aircraft. Purpose of our project: to show and elucidate the effects and implications aerodynamics have on our various objects. Also, we think that the amount of people who have knowledge about aerodynamics is low, so we would like to enlighten our peers about the beauty of aerodynamics. Our hypothesis is to show that aerodynamics have a substantial effect on the objects surrounding us. Whether they are small or big, aerodynamics play a big role in the respective object's movement. We believe that aerodynamics do play a big part in an object's movement. For procedure, we will gather many objects and point an air source directly at them. We will study how the object resists the air or travel with the effect of air resistance. Also, we will compare between them and see which objects are more or less aerodynamic. For our materials used: toy car, air source, solar panel, tape, tissue paper, glue, wires, and string. Results: we could see that aerodynamics practically affects everything around us. When we did the experiment on the toy car, we saw that the car's aerodynamic design reduced the drag in the car and increased the downforce on it. It also created an area of low pressure, increasing the stability of the toy car. Air resisted every object we put in front of it. Nevertheless, some objects were more aerodynamic than others. For example, the toy car was much more aerodynamic than the tissue paper. The air slowed all the objects to an extent so we could conclude that our hypothesis was correct. Conclusion: we think that our experiment was a success, and we are happy that our theory about aerodynamics is correct. We proved that aerodynamics do have an effect on objects around us. We hope that we could teach everyone a little about aerodynamics through our project. And thank you for listening.
Thank you so much. Now that is what we called an excellent display of skill and innovation. Well done, students, and congratulations to all of you. Now I would like to hand over to our principal ma'am, Mrs. G. Biswas, to share a few words with all of us.
Can I say something before that?
Yes, of course, my dear. Please take over.
Okay. My great thanks to all the CBS students. Thank you very much for all your efforts, and we look forward to more scientific success in our future. And thanks much to all of you and your contributions. Thank you.
Thank you so much. So moving on to our principal ma'am, Mrs. J. Biswas. Ma'am, if you could please share a few words with us.
Thank you so much, Anusha Miss. It was so interesting. So before I begin, I would like to express it's my proud privilege to welcome the chief guest of the day from Canadian Bilingual School, Kuwait, Jihan Mohammad Hassan. Thank you so much, ma'am, for being there, for supporting us, for joining this program. I also want to welcome, and it's so interesting that when I welcome Jihan ma'am, I have to say good morning. And when I welcome guest of honor, Mohuna ma'am, who is from Multicultural Academy, Michigan, USA, I say good evening. And to all my students here, to all my parents here on YouTube and on Zoom, I say good afternoon. So that's very interesting. In one place, it's good morning and good evening and good afternoon. So good afternoon, good morning, and good evening to all the students, to all the parents who has joined today to observe this science exhibition. And when we got a proposal from Canadian Bilingual School, and Jihan ma'am had given me this proposal to host it on 26th. Actually, 26th of January is a national holiday here. We hoist the flag because it is the Republic Day of India. But when I got the proposal, I was very happy to host it today because it is the Constitution of India, which came into effect on 26th of January 1950, and we celebrate it as a Republic Day. Now, the Constitution of India, if I look into the preamble, which is the introduction to the Constitution, it talks about equality, it talks about fraternity, brotherhood, and it also speaks about liberty of thought and expression. So if this is the day, so I thought, what better way to celebrate the Republic Day of India than to have a science exhibition and collaborate with the country across the world. Nothing better. So this was one of the reasons that we joined together today. And I thank Jihan ma'am for suggesting this day. I think nothing could have been better. So this is number one. Number two, if I look at the performance of the students, those who have taken this effort from Canadian Bilingual School, I would say you were superb. All of you were extraordinary, magnificent, superb. The presentation was so well done. So I thank you all for participating in this science exhibition. And it was a great, great effort from your side. And I hope you will enjoy what will be put up by the students from our school also. The third thing that I want to mention, and again, I will thank your school for this, because I was very much interested into doing this international collaboration, because what better way to teach children what to learn globally than to interact with students across the world directly, learn from them, actually learning it together. What I appreciate in this collaboration, yes, certain things are different in our education systems, but then when you join together today on this scientific platform, on the exhibition of science, you will also find the similarity. So that is to be appreciated. The similarity has to be appreciated and the difference has to be learned from. So this collaboration is very, very close to my heart as a school. And I appreciate that Canadian Bilingual School has been there with us, always cooperating with us and always joining us on this collaboration. I believe, all of us believe, schools across the world, we believe that we want to bring about learning outcome. We want to teach you, and what better way than to teach you in this way through a practical experience across the world. And last but not the least, why we took up the science exhibition, because I believe that science reveals the truth. Science is something which will come out in the future. Certain new innovations from you all will come out in the future. And if you heard Mohana ma'am and you will hear Jihan ma'am later, you will see that you are the future of the nations. Whichever nation you belong to, you are the future. You will be the people who will take the country forward. So it is very, very important that we take part in this exhibitions where your creativity, your innovation is showcased in science. So that is why it is a science exhibition. Thank you again, Canadian Bilingual School, for joining us, and I hope you will enjoy the rest of the program. Thank you, and over to you, Anne Shams.
Thank you so much, ma'am. Thank you for always motivating and guiding our students. Moving on with the program, I call on Shriparna to carry on with the proceedings. Over to you, Shriparna.
Thank you so much, ma'am. Now, we begin to present the science exhibit of the students of St. Augustine's Day School, Barakpur. At first, we begin to present the science exhibit of the students of class 6. The first participant is Ishan Laha, who is going to show us the working of a hydraulic arm. Over to you, Ishan.
Thank you. Good afternoon, one and all present here. Today I am going to present before you my hydraulic arm. So, my model is a hydraulic arm made out of several injection syringes of different capacities. So now I will show my machine picking up this small bottle and transporting it to a new position. So with the blue fluid syringe, I'm opening up the grabber, and now with the red fluid syringe, I am decreasing the reach of the grabber and grabbing the object. So now I am picking the object up, and with the yellow fluid syringe, I am rotating the arm, and now I am keeping the bottle to its new position. Now again I am rotating the arm to its new original position. So the syringes of my machine works on the basis of the chart. For example, when the water pressure created by pushing the syringe, water travels to the second syringe and it pushes the piston of the second syringe. And when I pull the syringe, vacuum creates and water rushes to the first syringe and came out from the second syringe. Now for the utility part. My machine is a small replica of the big and official hydraulic arms used in factories to pick up heavy loads which human hands cannot pick up. This system is also equipped in excavator machines to dig up soil and break heavy rocks. Thank you.
That was great, Ishan. We move over to Noirit Basu, presenting his experiment, Hardness of Water. Over to you, Noirit.
Thank you so much. Good afternoon to one and all present here. So today, my topic is the hardness of water, which is brought about due to the presence of soluble chloride, sulfate, and bicarbonate salts of calcium and magnesium in the water. So I will be performing a few simple chemical tests to detect the presence of calcium, magnesium, and chloride ion in the tap water. So let's begin. First of all, let's see how can we detect the calcium and magnesium in the water. So accordingly, a sample of tap water and a sample of distilled water will be taken in two of the test tubes. Then ammonia buffer of pH 10 will be added to both of the test tubes, followed by the addition of 1 pinch of an indicator called modern black tea. Now, if the solution turns purple in color, it indicates the presence of the calcium and magnesium salts in the tap water. So it is hard water. And as you can see, in the case of distilled water, the solution turns blue in color, indicating that distilled water is free from calcium and magnesium salts. In other words, it's free from hardness. Now let's move on to our third test to detect the presence of chloride ion in the tap water. A sample of tap water is taken in the test tube and dilute nitric acid is added to it. Then a few drops of silver nitrate solution is added to this test tube. Instant formation of white colored precipitate of silver chloride indicates the presence of chloride ion in the tap water. Thank you. That's all from my side. Over to you.
Amazing, Noirit. We move over to Srijita Das, who is going to show us the functioning of the human urinary system. Over to you, Srijita.
Good afternoon, one and all present here. I'm Srijita Das from Class 6, Section 8, and I have prepared a working model of the urinary system, named Kidney, a System for Existence. It consists of some organs named the kidneys, ureters, urinary bladder, and the urethra. The function of the urinary system is to balance the body's fluid, excrete nitrogenous waste, and filter blood for the formation of urine. The urine is actually a typical yellowish fluid consisting of water, urea, and other substances of our body. The kidneys form the urine and account for the other functions attributed to the urinary system. And the ureters carry the urine away from the kidneys to the urinary bladder, which is a temporary reservoir for the urine. And once the bladder gets filled, it is moved out of the body with the help of the urethra. In this model, the blood is getting filtered into the two kidneys, and the waste is passed through the ureters to the urinary bladder. And once the bladder is full of waste, it is moved out of the body with the help of the urethra. This was what my demonstration was all about. Thank you.
It was very nice, Srijita. Following Srijita, we have Siddharth Shankar Ghosh showing us the working of a homopolar motor. Over to you, Siddharth.
Thank you so much. Good afternoon, everyone.
Today, I am going to show my project named Homopolar Motor. As you can see, a homopolar motor is running in front of me. So what is exactly a homopolar motor? It is a special kind of motor whose electric polarity of the conductor and the magnetic field poles do not change. To make the homopolar motor, I used a copper wire, which is the conductor, the battery, the supply of electrons, and neodymium magnets, which provide a magnetic field. The copper wire moves due to the interaction of the electric current and the magnetic field. Has it got any applications? Definitely yes. It is used in remote controlled toys, windmill turbines, and a special missile called railgun, which is faster than the speed of sound and does not require gunpowder for ejection. Thank you.
That's great, Siddharth. We move over to Rajeshwar Shil, who is going to show us the functioning of the human respiratory system. Over to you, Rajeshwar.
Thank you so much. Good afternoon to one and all present here. My name is Rajeshwar Shil. So today I am going to present a journey to respiratory system. Just give me a moment. What did I do? I inhaled and exhaled. How? Let me show you all. Respiratory gases are exchanged between the human respiratory system and the environment. Oxygen is needed for various processes in a human body, and the excretory product carbon dioxide should be given out to the environment. So about that, I have prepared a model on a human respiratory system. So when I blow air, I will initiate inhalation. Before that, I will show my parts in my model. So as you can see, here is the pharynx, here is the larynx, here is the trachea, here is the bronchi, here is the bronchioles, and here are the lungs. Means that air sacs. So when I blow air, I told you that I will initiate inhalation, which is a process of taking in oxygen for various processes. Now I will give the air. As you can see, the lungs expanded. This means the lungs have taken in the oxygen for various processes in a human body. Now, when I will remove the air from the lungs, this means I will initiate exhalation, which is the process of giving out the excretory product carbon dioxide to the environment. Let me show you all. As you can see, the lungs contracted. This means the excretory product carbon dioxide has been given out to the environment. And that's how my respiratory system works. Thank you. That's all about this. Have a nice day. Over to you.
That was so informative. Next, we have Goirik Ghosh and his experiment, Nature O Fresh. Over to you, Goirik.
Good afternoon, one and all present here. I am Goirik Ghosh, and today I will present before you my exhibit. The name of my exhibit is Nature O Fresh. To begin with, let me introduce you to my project. My project is made up of a miniature conveyor belt and a vacuum machine. Coming to the crux of the matter, my project is mainly aimed to aid farmers. When the farmers pick the vegetables from the field, they will be put inside the packet like this, and then they will be put on the conveyor belt. The conveyor belt would convey them up to the vacuum machine, and as soon as it reaches there, I will insert the mouth of the packet on the nozzle of the vacuum pump. And now when I switch it on, you can see that the air inside the packet is being sucked out. And when we see that almost all the air has sucked out, we will slowly close the mouth of the packet, take it out and switch off the vacuum pump. Now, you can see here that the vegetables are totally kept away from the air, which means they are fresh and can be preserved for a long time without the use of any refrigeration process. After this, they are ready for dispatch and sale in the market where customers can buy field fresh vegetables. Thank you.
Splendid, Goirik. We move over to Avinivesh Shaha, who will show us how to prepare a homemade slide projector. Over to you, Avinivesh.
Good afternoon, one and all present here. I'm Avini Shaha, and today I'm going to show my homemade slide projector. So as you can see, this is my homemade slide projector, which consists of a torch and a magnifying glass. These are my slides, which I have made on cellophane paper with the help of glass colors, and I will be presenting them on the screen. So, as you can see, this is the plain white wall of my room, which I will be using as the screen. I have turned off the lights, and now the slides are being presented one by one. The utility of my project is that it can be used in information to mass gatherings in the teaching. So, this was all. Thank you. Over to you.
It was very creative. Following Avinivesh, we have Mikhail Rizwan Ali and his experiment, solar irrigation. Over to you, Rizwan.
Good afternoon, one and apprentice. As you can see, my model is about solar irrigation system. Before presenting my model, I would like to explain what is solar irrigation system. Solar irrigation system is a system in which sun's energy is used to power pump for supplying water to the crops. As we all know, India is an agrarian country. More than 60% of India's population are dependent on agriculture. Factors that influence crop yielding are fertility of soil, right climatic condition, right amount of water, control of diseases and pests. To overcome the scarcity of water using solar irrigation purpose, solar irrigation system is a beneficial way and it is a pollution-free system. No greenhouse gases are emitted after installation. It reduces the use of pollution. It reduces the use of fossil fuel and other foreign oils. So now I am going to present my model. As you can see, when sun rises, sun's rays fall on this solar panel and this solar panel converts the sun's energy to electrical energy and then the electrical energy is passed to the pump and this pump draw water from this pond and load into the tank and when needed soil is irrigated. How? Let me show you. Something like this. Thank you. Hope you all like my presentation and have a nice day.
That's great, Rizwan. We have our last participant from class 6, Oishi Paul, presenting her electric lift. Over to you, Oishi.
Thank you. Good afternoon, one and all present here. Now, tell me, having a knee problem? Cannot climb the stairs? Need to lift heavy load from one floor to another? Don't worry. I'm here with my electric lift as your aid. Here you can see I have a dry cell and a DC motor. Now, when I will do the connection, my lift will go upwards. And now, as soon as I will do the opposite connection, my lift will go downwards. And absolutely everyone can make use of it. That's all for today. Thank you.
That was remarkable, Oishi. With this, we come to an end of the participants of class 6. Now, I would like to hand over the platform to Ritoja. Over to you, Ritoja.
Thank you, Sriparna. Good afternoon to one and all present here. Now, we will begin with the participants of class 7. The first participant is Shrestha Chakraborty, who will show us the circulation of the heart. Over to you, Shrestha.
Thank you. Good afternoon to one and all present here. Today I am here with my exhibit, the heart, which is the key of all of our lives. Now, what is the heart? The heart is a muscular organ located in the chest, right between our lungs, and is protected by the rib cage. Did you know that our heart beats over a lakh times in a day and works as an extraordinary pump? Now, the heart has many different parts. Let me show you what they are. The heart has 4 chambers: the right atrium, the left atrium, the right ventricle, and the left ventricle. The heart also has 4 valves here, 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 and here. They basically prevent the backflowing of the blood. This tube is known as the inferior vena cava. This tube here is known as the superior vena cava. These tubes are known as the aorta. This tube here is known as the pulmonary arteries, and these tubes are known as the pulmonary veins. There is also a partition in between that separates the pure blood from mixing with the impure blood. Here I have used blue-colored water to represent the carbon dioxide-rich impure blood and red-colored water to represent the oxygen-rich pure blood. Now let me show you how the heart functions. So first, carbon dioxide-rich impure blood from the body transfers into the superior vena cava to the right atrium to the valve to the right ventricle, then out from the pulmonary arteries into the lungs for the process of purification. Now, after the process of purification in the lungs, the carbon dioxide-rich impure blood becomes the oxygen-rich pure blood. So the oxygen-rich pure blood then from the lungs transfers from the pulmonary veins into the left atrium, to the valves to the left ventricle, then out from the aorta into the different trillions and billion cells in our body. Would you be surprised if I say that all the processes take only about a few seconds to happen? Thank you.
Wow, that was remarkable. Next, we have Swapnanil Ghosh with his exhibit Natural Indicators. Over to you, Swapnanil.
A very good afternoon to one and all present here. Today, I will show you how a natural indicator works. The materials required for this experiment is China rose juice. I have 2 glasses of China rose juice here, some pieces of lemon, and detergent solution, that is detergent plus water. First, we will work with 1 glass of China rose juice and keep the other aside for some. Here, we will add lemon. As we know, lemon is an acid. Adding lemon, that is acid, turns this black colored solution to reddish pink. Now we will work with this glass of China rose juice, and here we will add detergent solution and stir it well. Detergent is a base, so adding detergent turns this solution to dark green. So this was my experiment. With this test, we can easily identify anything to be an acid or a base. Reddish pink or any shade of red will prove it to be acidic in nature, whereas any shade of green will prove it to be a base. Thank you.
That was splendid, Swapnanil. Our next participant is Adriza Biswas, who will be showing us the disappearance of eggshell. Over to you, Adriza.
A very good afternoon to one and all present here. Today, I'm showing disappearance of eggshell. So let's start. At first, I have taken a glass filled with vinegar. Now I will drop an egg in it. And I will keep it aside for 24 hours. Now I will show you the difference between the current situation of the egg and what will happen after 24 hours of keeping it aside in vinegar. So here are the 2 results. As you can see in the first case, the egg is hard and it contains eggshell. But in the second case, the egg is soft, squishy and bouncy, and it does not contain eggshell. Now, let me explain. Eggshell contain calcium carbonate, which reacts with acetic acid present in vinegar to form carbon dioxide, water, and calcium acetate, due to which the eggshell disappears. Thank you.
Wonderful, Adrija. Following Adrija, we have Ishika Sarkar, who will show us the rise in the temperature due to respiration. Over to you, Ishika.
Thank you. Good afternoon to one and all present here. The simple aim of my exhibit is to show that respiration produces energy in the form of heat. To do this experiment, I have used 2 glasses, some soaked seeds, some dry seeds, some cotton wool to trap the heat inside the glasses, and 2 thermometers to measure the temperature rise and fall in the glasses. So as you can see, I have done this setup a few minutes ago. So now let's see if there is any final reading. And a small note, my initial reading while doing this setup was 98 degree Fahrenheit. That is my room temperature. So let's see what is our final reading. First I will start with this glass containing the dry seeds. So as you can see over here, it shows 2 letters LO. This represents that my thermometer is now at the room temperature 98 degree Fahrenheit. So the final reading and the initial reading in this glass is same. That means there was no rise in temperature in this glass. So let's move on to the next and see what is this reading. Yeah, this has a different reading for us. If you can see, it shows a 105.1 degree Fahrenheit. And it is different from our initial reading. So we can say that there was a rise in temperature in this glass. So now with this difference between the initial point 98 degree Fahrenheit and the final point 105.1 degree Fahrenheit, we can conclude that yes, respiration produces energy in the form of heat. That's all about my exhibit. Thank you. Over to you.
Fantastic, Ishika. Our last participant from class 7 is Anfal Mushtaq, who will show us the existence of air pressure. Over to you, Anfal.
Good afternoon, everyone. Today I'm going to show the existence of air and air pressure. As you can see, I have already inserted a balloon in this empty bottle, and now I'll try to blow it. When I try to blow the balloon does not expand. This means air has already occupied space inside the bottle. Now I will make a hole in it. And again try to blow the balloon. This time the balloon expands. This is because air inside the bottle moves out through this tiny hole. Now let me blow the balloon and cover the hole. Now I'll pour some water in this balloon. Let's see what happens when I remove my thumb from the hole. The water spills out of the balloon. This is because the air inside the bottle creates a pressure on the balloon. Therefore, it moves out of the balloon. Thank you.
That was great, Anfal. With this, we come to the end of the participants of class 7. Thank you. Now I would like to hand over the platform to Sriporna to carry on with the proceedings. Over to you, Sriporna.
Thank you, Rituja. With this, we begin to present the science exhibit of the students of class 8. The first participant is Debarati Datta, showing her experiment fire extinguisher. Over to you, Debarati.
Good afternoon, everyone. Today, I'm going to display the working model of fire extinguisher. Firstly, I will be adding this vinegar into this bottle containing water. Now, this napkin containing baking soda will be placed into this bottle without touching the solution. I will close this bottle with this spray cap. Now, my fire extinguisher is almost ready. Let's check it. The fire gets extinguished. Now you must be wondering how it works. The baking soda, which is sodium bicarbonate, and vinegar, which is acetic acid, reacts to form carbon dioxide gas, which is a non-flammable gas. Being denser than oxygen, it displaces it and cuts the supply of the oxygen. Therefore, the fire gets extinguished. Thank you.
That was so informative, Debarati. Following Debarati, we have Anushka Biswas, who is presenting her model conveyor belt. Over to you, Anushka.
A very good afternoon to one and all present here. I am Anushka Biswas, and today I'm going to present my exhibit, Conveyor Belt. So, my exhibit basically contains some common materials like some plywood bases, some shaft stakes, a resin sheet, mount cardboard pieces, board PVC pipes, and a synchronous motor. Now, let's check on the observation. I'm going to place the objects in the conveyor belt. So a conveyor belts are the continuous moving strips that are driven by motorized mechanism that are used for carrying different type of heavy material from one place to another, and that is majorly inclined by nature. We all can see that the object is traveling from its initial place to another place. That is because of this synchronous motor working on the conveyor belt. This machine has an important utility in the material handling sector, and in our everyday lives, we can find these kind of mechanism in the airports. In the airports, this mechanism is used to carry the luggages of the travelers. And therefore, we can say that this machine is a replica of the daily carrying medium. Thank you.
Splendid, Anushka. We move over to Shomalya Datta and his experiment, water level indicator in a water tank. Over to you, Shomalya.
Good afternoon to all of you present here. Today, I am going to show you a working model on water level indicator for water tank. In everyday morning, we have to switch on the pump to store the tank. So I have switched on the pump. The buzzer is ringing. That means we have to switch off the pump. The buzzer is ringing, indicating us the water is nearly full in the water tank. In everyday morning, we switch on the pump and forget to switch it off. So if we install this circuit, the buzzer will ring and indicate us to switch it off. In the latter half of the day, we use this stored water in various places. So we cannot recognize the water level gets decreased in the water tank. We also cannot recognize when to start the pump. So this indicator light will indicate the level of water in the water tank. When this two indicator light will glow, it will indicate that 50% of water is left in the tank. When green indicator or only one indicator will glow, it will indicate very less amount of water is present in the tank, and that is the time to restart our pump. The main aim of this project is to reduce water loss and also to reduce electric consumption. Thank you. Over to you.
Remarkable, Shomalya. With this, we come to an end of the participants of Class 8. I would again like to hand over the platform to Ritoja. Thank you. Over to you, Ritoja.
Okay, so Rituja might be facing some network issues. She has.
Yes, ma'am, I'm here.
Okay, she's back. Carry on, Rituja.
I'm so sorry. Yes, thank you, Shriporna. Now we will begin with the participants of class 9. Our first participant is Ankita Kormukar with her beautiful show of Sugar Rainbow. Over to you, Ankita.
Thank you. Good afternoon, everyone. Today, I am going to show sugar rainbow experiment. For this, we will first use a syringe and start with glass number 1. Glass 1 contains water and 1 spoon of sugar completely dissolved. I have added yellow food color in glass 1. We will then move on to glass 2. Glass 2 contains the same amount of water as in glass 1, completely dissolved. I have added green food color in glass 2. We will then move on to glass 3. Glass 3 also contains same amount of water and 3 spoons of sugar completely dissolved. I have added red food color in glass 3. We can here see a rainbow of 3 colors. This happens because as we increase the amount of sugar in the solution and keep the amount of water constant, we are actually increasing the density of the solution. A solution with lower density stacks on top of the solution with higher density. Thank you.
Beautiful, Ankita. Following Ankita, we have Aksa Shamima with her display of muscle magic. Over to you, Aksa.
Good afternoon, everyone. This is my exhibit, Muscle Magic. We know that muscles help to maintain our body postures and also provide the means of all movements. Most muscles are long bundles of contractile tissues. Each muscle usually has two ends. First, a fixed end from where it originates. Second, a movable end which pulls some other part. Most actions in our body, like walking, standing, laying, etc., require combined actions of several muscles. To a great extent, muscles have to be coordinated for a particular movement. A structure which has been moved by a muscle cannot return to its original position without the action of another muscle. Such muscles causing opposing movements are called antagonistic muscles. The balloon here is the biceps muscle, this is the upper arm, and this is the lower arm. The biceps muscle of the upper arm contracts, that is, bends the lower arm over the upper arm. Straightening of the lower arm is brought about by the triceps muscle. During this time, the biceps relax. Now let's see how it works in my model. But before I begin, I would like you all to check the position of the lower arm. It is away from the upper arm, right? Now let's see what happens when the biceps contract. We can see that the biceps has expanded, bringing the lower arm closer to the upper arm. This is flexion. During extension, the biceps muscle has relaxed and the lower arm has moved away from the upper arm. In this case, the triceps have contracted. Thus, I will conclude by saying that biceps and triceps muscles are antagonistic in nature. That is, they work opposite to each other. That's all I have to say. Thank you.
That was splendid, Aksa. Last but not the least, we have Roshni Datta and Sudarshana Ghoshal who will display the magic in the eyes of the beholder. Over to you.
Good afternoon, everyone. We will be performing some magic tricks. Now I will prepare a magical stuff named love. This stick is made up of a shiny substance and I'll burn it to produce love. Aluminium luminosa Can you see this loft? Then I'll spray this magical mist. And now watch the magic. This is magical loft.
Wait a second. Before you finish, I have something to say. That is not magic. Magic is in the eyes of beholder. That is not a magical substance. She is basically using aluminium foil roll which has matchsticks in the head part. Afterwards, she is using a glass jar to collect the smoke. Then she's spraying a deodorant and calling it a magical mist. Then she shows you the Luft, which basically means smoke in German. Today, I will show you some real magic. Here, I have with me a white potion and I will turn it dark with my magical wand. So watch it as I draw. Aluminium Kolorova. This will slowly turn dark. And on igniting it, it burns with a pop sound and turns even darker. This is the power of effervescence. Do you see the convulsive effect? Well, isn't it supernatural?
This is not supernatural. Supernatural is a null word. This is science. My witch friend is using caustic soda and water to prepare that white solution and then adding crumbled aluminium balls available in all ordinary shops into it. Now basically the pop sound is occurring as the colorless odorless gas hydrogen is evolved, leaving a black residue. So she is just using homemade items to prepare hydrogen gas.
So don't let others fool you by these tricks. This is simply science.
Magic is in the eyes of beholder. Thank you, everyone.
That was a marvelous presentation and an extraordinary show of teamwork. With this, we come to the end of the participants of Class 9. Thank you. Now, I would like to hand over the platform to Anvesha ma'am. Over to you, ma'am.
Thank you so much, Rituja. That was extremely innovative, and congratulations to all the participants for all your hard work. We are indeed honored to have with us Madam Jihan Mohammed Hassan, Principal, Canadian Bilingual School. She has over 27 years of experience in the educational field and has done her master's in education from Mansoura University, Egypt. She has obtained her teaching certificate from Delaware University, USA. She has also received Certificate of School Management and Leadership from Harvard Graduate School of Education. We are so happy to have you with us, ma'am. I request you to please share a few words with us.
Thank you very much. And I'm very impressed indeed. Thank you for the nice introduction and thank you for that amazing collaboration today. Distinguished guests, young scientists, ladies and gentlemen. I'll say good day to everyone because we are spread all over the world. It's my great pleasure to be here today. First, I'd like to congratulate you on the Republic Day celebrations today, and thank you for accepting our date that we assigned today, even if it was a holiday on your side. Thank you again. I kept that in my letter as a final note, but I'll start with it. I'd like to thank my colleague, Ms. Janet Gasper Chaudhry, and I'm saying it was a great pleasure being your colleague at Harvard when we studied for our certificate of school management and leadership, as education is leading to more education. The whole idea of the collaboration started in one of our team projects together, and here we are together all over the globe sharing a science exhibition. I'd like to thank Mrs. Jay Beswas, the principal of San Augustine's Day School, Barakpur, Ms. Sharmila, and the respected vice principals and coordinators for the outstanding efforts and cooperation along since the beginning of the year. Huge thanks to our science team under the leadership of Ms. Lina Dajani and our IT support led by Mr. Shiva, of course. Thanks to all students, thanks to your students, teachers, and the whole staff. I'm most happy to see so many brilliant young scientists from Kuwait and India at this first collaborative science exhibition between Canadian Bilingual School and San Augustine's Day School in India. The collaborative science exhibition is an important occasion for students from our side and yours to share ideas, exchange thoughts, and I'm sure this exhibition will inspire hundreds of young people in the future. It offers students a precious opportunity to showcase their achievements, which can motivate them to further their pursuit of scientific knowledge. Here, I'd like to express my deep appreciation of the efforts of all students of Canadian Bilingual School and San Augustine's Day School, science exhibition preparations committees, which has made that event an overwhelming one. Through the efforts made by all students, teachers, and staff members, this event was made possible. To all students, it gives me immense pleasure to be part of your science exhibition. As I can see, all of you have done a great job in creating very good demonstrations and models illustrating various scientific equipment and experiments. The biological models were extraordinary. The explanation was like top. It was really good to see the dedication you have put towards contributing in this exhibition, the excitement that has been showing in students' presentations. Science is a very interesting field, and I request all of you not to give up on your passion for this. I wish you all the best for your future endeavors. Thank you very much.
Thank you so much, ma'am. Thank you so much for all your inspiring words and encouraging words. We feel honored to have with us today our president, ma'am, Mrs. Janet Casper Chaudhary. Ma'am has been serving the governing body of St. Augustine Education Society for over 25 years. She has spent most of her career in corporate world, having worked in leading companies like ABN, Amro Bank, Nestle, and Price Waterhouse Coopers, an MBA from XLRI Jamshedpur, and an alumnus of Trinity College, London, and St. Xavier's College, Kolkata. She guides the school management on most matters dealing with human resources, new initiative, and infrastructure. She also helps with the Proud to be Augustinian program that serves the community. We are so happy to have you with us, ma'am, and I request you to please share a few words.
Thank you so much, Onisha. And good afternoon, good evening, and good morning to everyone watching live in different parts of the world. Yes, my first gratitude goes out to Jihan. I never realized when you and I collaborated in our school leadership program back in Harvard that it would culminate into something like this today. It this is beyond words fantastic. Having a proposal come from you, having my teachers and students so excited to prepare all of this and do it. Yes, it's a holiday, but I don't think that matters to them because this collaboration, I think, means so much to my teachers and the students. I joined in maybe a little late, but I started watching all the exhibits of your students at Canadian Bilingual School, and I was so impressed just to hear them speak and to see the kind of experiments they were putting up And I'm very, very sure that our students have enjoyed it as much as all of us as teachers have done. I just wanted to know that are all your students watching this live in a particular place, Jihan, or together? I mean, how are they watching it?
No, actually, they will be watching it in the afternoon today as a recorded.
Oh, I see. Okay.
Yeah.
All right. So whenever they watch it, to the students, my dear students of Canadian Bilingual School, I have a deep gratitude and thank you to all of you, because it is your effort, my dear students, that is making the difference in your school. And that is a difference that we are also facing here. A long time back, when we were your age, we didn't have all these fancy technology systems. And what we used to do is we used to write letters to each other, and we had pen pals in different parts of the world. But today, I would encourage all of you to get to know each other, to share your knowledge, to talk about the cultures, to talk about science, to talk about all the different ways of learning, because there's no better way to learn than to collaborate with each other. So, a big thank you to all the teachers at Canadian Bilingual School behind this entire effort. A big thank you to my principal, Jhuma ma'am, and her entire team for putting this together. I'll reiterate by saying I cannot believe how fantastic this collaboration has turned out. Thank you once again, Jihan, and I look forward to many more programs with Canadian Bilingual School. Thank you so much.
Thank you, dear. Thank you. I believe we should send that to Harvard, Janet.
Yes, yes.
We have to send that video to Harvard and say thank you. Collaboration worked very well. Our teamwork paid off.
Absolutely. I think it's a great idea. Let's do that.
Yeah, we will. Thanks to all. Thank you.
Over to you, Anisha. Thank you so much.
Thank you so much, ma'am. Your words have always been a source of inspiration for all of us. Moving on, no event can be successful without acknowledging the efforts of all the people involved in it. I request our Vice Principal, ma'am, Mrs. Shweta Ray, to come forward and deliver the vote of thanks. Over to you, ma'am.
Thank you, Anisha, Miss. And good afternoon to everyone. It's my proud privilege to give away the vote of thanks on this special day. It is our Republic Day, a special day, and more special because on this special occasion, we could collaborate with this school, which was a dream for us. We wanted to collaborate. And on this special day, we are collaborating. Thanks so much, Jihan ma'am, for collaborating with us. Now, I want to wish everybody Happy Republic Day. Now, Jihan ma'am, yesterday when we interacted with you, you said something which I'll not forget. You said it is a long relationship. And I'm sure we'll be having more such collaborations with you. And maybe after this science exhibition, we can have a sports with all of you. And with this collaboration, I'm sure our students have learned a lot because science, the concepts remain same, and they have presented all different kind of concepts. So something your students must have learned from what they have presented, our students have presented, and that was the purpose of this collaboration. So that they understand that across the globe, how things are happening, in which level what is being taught. So we will be looking forward for such collaborations more. And thank you so much for joining with us. I want to thank you teachers and students and definitely congratulate them. It's a wonderful show, excellent. We really loved it. It was excellent to watch such a beautiful performance by all your students. So my congratulations to those children and their parents, and of course the teachers. Thank you so much for being a part of this collaboration. I want to thank Mohana ma'am also, principal of Michigan School, Multicultural Academy. The way ma'am expressed her feelings and motivated our children. Thank you so much, ma'am. I'm sure maybe someday from some students from our school will be in NASA, and we will be proud to see them there. I want to thank our President, ma'am, Mrs. Janet Gaspar Chaudhary, and our CEO, Sir, Mr. Amitabh Chaudhary. It is Sir and ma'am who inspire us and tell us to think beyond boundaries, to extend and stretch ourselves, and that is why this collaboration could happen today. Thank you so much, ma'am, for giving us these thoughts to think beyond the boundaries. Thank you, ma'am, once again. I want to thank from bottom of my heart to all my parents and students, and all of them, hundreds of students there in the YouTube, and they all on a holiday, parents and students there. Thank you to the parents, especially to those parents, those who have motivated children to take part in this science exhibition from their home. In this pandemic, they're at home, most of them are. And thank you, parents, for encouraging them. Please keep encouraging your students and supporting us. Your support motivates us to take up these challenges. I want to thank all my headmistress, coordinators, CCA coordinators, all of them, and especially the science teachers for making this day a successful one. Thank you to my MC, Anisha Miss, and also the student who is presenting this entire show, Omlan. Thank you so much, everyone. Over to you, Anisha Miss.
Thank you so much, ma'am. Thank you so much. So we have come almost to the end of our program. Let us all join the school anthem. Thank you so much, everyone. Thank you for joining. We can now all log off.